Everyone possibly knows this statement in physics. Energy can't be created or destroyed. Though, how can it be proved that this law is true and important for the essentials of physics? We need to know what energy is. It's a term we use a lot in our daily basis, but in physics, it's a bit different. Energy is the ability of doing work. The unit for energy is joule. Energy exists in different forms, such as kinetic, gravitational potential, elastic spring potential, thermal, chemical, and the nuclear energy. Kinetic energy is the energy of motion. For example, when a dog runs. Potential energy is the energy associated with an object's position or simply an object's height above the ground. If you throw up a ball, the potential energy is the biggest when it reaches at the highest point. Elastic potential energy occurs when an elastic object is stretched. As an example, stretched rubber sling can be given. Thermal energy is basically energy in the form of heat. It can be also said as a sum of the kinetic and potential energies of the molecules in an object. You can observe the thermal energy while drinking a coffee. Chemical energy appears when bonds form in a chemical reaction. For example, the batteries you use contain chemical energy. Nuclear energy is the energy in an atom's nucleus. We said that the energy is neither created or destroyed, so what happens when we use these forms of energy? They transform into another kind of energy. For example, when a weightlifter lifts a barbell, the chemical energy gained from tons of food transforms into gravitational potential energy of the barbell. Or, while riding a bicycle, your chemical energy turns into thermal energy, which creates a slight heat on the wheels, and also mechanical energy, which leads your bicycle to move. What very important is that in all these transformations, the total energy remains the same. To give a proper definition, we can say that the total energy is the sum of the energies present in the system. Though every physical system also associates with its environment. So, the passing energy from a system to environment or the opposite is called energy transfer. This transfer of energy can be work or heat. Work is when a force is applied to an object and the object moves a distance. The law of the conservation of energy will be more understandable now. If we do a quick summary, what we've learned so far is energy is a capacity of doing work. It exists in various forms. These forms transform into another kind. Energy exchange between a system and an environment is called energy transfer. This is called work. The sum of all the present energies give the total energy. The total energy always remains constant. Let's think an isolated system, which means it isn't affected by any net external forces. In simpler words, no work is done on it. In an isolated system, the total energy of the system is conserved, so zero. These examples will blow your mind and help you to understand the conservation of energy through the most joyful way. If we make a pendulum using two water bottles, placing them with a distance, and then give a force to pendulum to make it slide, we can observe as it is about to stop, the other bottle will start moving. It can be deduced that the energy of the first bottle transfers to the second bottle and makes it slide, so the energy is conserved. In this experiment, if you release the pendulum from your chin, ignoring the friction force, it won't hit you but will come back to you again. This is the best way to represent energy transformation and conservation. At the very first moment, it has potential energy, but the kinetic energy is zero. At this moment, the kinetic energy is at maximum, but the potential energy is zero. When it arrives at the third moment, it will stop for a little amount of time. There will be its potential energy maximum, and the kinetic energy is zero, so the total energy remains always at the same rate. It is conserved. To conclude again, energy can't be destroyed or created. It transforms from one form into another. We can understand that energy is everywhere and takes up the whole universe. With this law, we come one step closer to discover the mysteries of the universe.